Hi everyone, I'm Yusuf and I'm a 4th grade aerospace engineering student at Middle East Technical University in Turkey. In this video I'm going to talk about my Matlab and Simulink project, which is modeling and simulation of a F-16. In this project I use Matlab and Simulink simultaneously. I'm using the Matlab to decide the flight conditions, to trim the aircraft for that flight condition, and then for linearization. In Simulink, I have actually two models, which are nonlinear and linear models. Let's have a look at the nonlinear model. The nonlinear model consists of 4 inputs and 15 outputs. 4 inputs are control inputs from control surfaces of the aircraft, and by using that inputs and the trim conditions we have found, I can calculate the aerodynamic coefficients. By using that coefficients, I can calculate the forces and moments acting on the aircraft, and by using that forces and moments, I can solve Sixth equation of motion. And then I can find the change with respect to time on all states, and then by integrating them, I can find the overall outputs of the system. In here, in plants, this block calculates the aerodynamic forces and moments, and this block solves the sixth equation of motion. Let's have a look at the linear model. In linear model, we have a state space block here. A, B, C, and D, which are inputs on this block, are calculated in Matlab. After the calculations, I'm given the inputs, and the things in left-hand side are just a control system. I'm just controlling them by using feedback control systems and PI controllers. Let's run the model. After selecting the altitude and velocity and the flight conditions, it founds the trim and displays the trim values. Then it asks for the inputs for linearized model. See the results in linearized model, I just run the code again, but with changing the CG, which will make the aircraft unstable to require the control system. I give the delta inputs like that. I want a change in velocity at as minus 10 feet over seconds, and I want a change in altitude like minus 100 feet. Yeah, let's have a look at the results of a linear model. As you can see, they change as we want, and the others are just 0. That means they are not changing. And for the same flight regime, these are the results from nonlinear model. As you can see, there are diverging behavior from here, because the aircraft is unstable, and we can see the unstable behavior here. Actually, it's all about my project. I just wanted to learn the how to use the Simulink and Matlab by doing some projects like this. And this project is not very hard, I know, but it takes a long time to get used to the Simulink environment and the functions to call the Simulink models to Matlab. I learned very much from here. I experienced very much. And that's all about my video. Thank you for listening to me. Thank you for your attention. Have a good day.